Let f be the function given by this. Of the following values of x, at which does the line tangent to the graph of f have the greatest slope, and which has the least slope? So we want a greatest slope and a least slope, all right, for function f. And the tangent line is basically the instantaneous rate of change. So really, what we want to do is we want to, for a here, we want to find f prime negative 1.683. All right, so we want to approximate. So how would we approximate that? And we want to do each one of these. How do we do that? Well, you need a graphing calculator. This one we cannot visualize without a graphing calculator. Now, when I graph it, I could visually look at all these, but that also might be a little tough, but maybe not. It depends on how you are. So you could estimate it by looking at this graph when you sketch it. That's totally possible. Sketch it. What does it look like? And do it visually. And I would actually recommend that. But you can also very quickly, using your calculator, just find each slope. So when I use my calculator to find this, for the first one, I get, well, at least my calculator puts negative 0.002. All right, which basically what's going to happen, that's about 0. All right, and then the next one, when I find f prime of negative 3, okay, that's going to be, what does it come out about? It says it comes out about 12. And then the next one, we're going to do f prime of negative 5. All right, what does that calculator tell us there? It tells us 43.6. And then the last one, we do f prime of 2. And the calculator tells us that is 2.27. All right, so just by looking at these numbers, which is the greatest slope and which is the least slope? All right, so the greatest slope looks like it's this one, okay? It is going up very, very steep, the biggest. So we would say now that this one right here has the greatest slope, okay? So this one right here has the greatest slope. Now, which has the least slope? Well, the smallest number is this one, which is basically 0. Looks like there's a horizontal tangent line there. So where this one will be the least slope. We'll go right here. So this one would be the least slope. And again, you could have sketched it and looked at the graph, and you could have seen that this one would kind of be a horizontal tangent line, and this one at this point would be very, very steep. And that could totally work too. I just thought it'd be kind of quicker and easier. Just plug them in using your calculator, using Desmos or something to crunch the derivatives really quickly. The graph here crosses the x-axis at one point on 0 to 1. What is the slope of the graph at this point? To do this one, we need a graphing calculator. It really can't be done without a graphing calculator or Desmos. So the first step here is I'm going to do a quick sketch, just a quick little sketch here of what I see on my graphing calculator. I know my interval is from 0 to 1. So I have from 0 to 1 here. And when you see it, what you'll notice is we're going to go up 1, and you're going to see the graph. When you see it, you're going to see a graph that looks as kind of like follows. It goes up, all right, and then it comes back down and kind of goes something like that. All right, that's what it kind of is going to look like on the interval 0 to 1. Now, you have to know on a calculator how to adjust the intervals to see it maybe, but this one will probably come up nicely on the calculator. So with this, it says a spot where, one point where it crosses the x-axis. So the spot where it crosses the x-axis is right here. Now, how do we find that spot? Well, the spot where it crosses the x-axis, x is approximately, well, you have to use the features of your graphing calculator. There's a feature for zeros, and it's under menu, and you can, it's menus, analyze graph, and you can see that. Or if you have Desmos, you just look for it, click on it, and you can see it. Now, you want to put as many decimals as you can for the AP test. So when I use my graphing calculator, I make sure I get enough decimals, and I get this crazy big number right here. So that's the number I get. And I put it big because I want to be as accurate as possible. The Desmos won't give that many decimals, but your graphing calculator will. So this point right here is 0.727933. That is where you cross the x-axis, and the calculator gives that. Now, you can approximate it with your eyes and just guess, because this might be a multiple choice question, and you can kind of figure it out, estimate it. But this is the point. So this isn't the answer, though. This is where it crosses the x-axis. The question is, what is the slope of the graph at this point? So at this point, what is its slope? Well, you do notice it's going down. All right, we don't know how steep it is, but we do know it's going down. So you can kind of approximate, but now all you have to do is use your calculator. All right, and what you do is you do y prime of 0.727933. All right, so you do that, and when you do that, you'll get an answer that is about negative 4.14. And that would be the slope of this line right there. All right. So how do you find the slope at a point? Well, you should know how to do that by basically you just use the derivative function and use it on the graphing part and put in that number. But there's other ways. There's lots of ways to actually find that slope. So you cannot do this with that graphing calculator. You need it, first of all, to find the x-intercept. Then, after you find the x-intercept, you then need to find the derivative at that x-intercept. So hang in there. It'll all work out. This one is a little wordy and a little confusing, but it does make sense with some time and thinking about it.